to, don't forget to put down your name and where you are joining us at this moment right now. All right, we have about 15 participants online. All right, I want to welcome everyone to the Globe Mission Health Urban Heat Highland Intensive Observation Period webinar series. This is the second webinar this year. Second webinar. We had the last one in February last year, and this is the first one of this year. So I want to welcome you to this second webinar, which is going to cover a lot of things. But at this moment right now, we are focusing on where you could come in as participants, as scientists, as citizen scientists, and it's a webinar that is going to open your heart, your mind to Urban Heat Highland investigation as a campaign. Before I go further, I would like to introduce my name and some of my colleagues that I have right online now. All right, my name is Olawale Oluwafemi, but for short, you can call me Femi. I am a 50-year doctoral student in the Department of Geography and Planning at the Department of Geography and Planning, University of Toledo, Ohio, United States. And I have a couple of people right with me online now that we work together. I want to say shout out to Sarah. She's also here, which is going to be one of our guest speakers tonight. And I also have my boss online, Dr. Kevin Sarkowski. We normally call him Dr. C, who is also going to speak to us later today at the end of as we are trying to wrap up the program. All right, so I'm going to go back to I can see Dr. Mary too, she's online. And we have a couple of people online tonight from Globe Mission Health. All right, so I'm going to quickly go straight to what we have in stock for today. I hope everyone can see my slide. Let me just see if I can do it right here now. All right, can you all see my screen?
Yeah, we're seeing the title slide.
Oh, okay. All right, so let me see if I can flip through. All right. So like I've said earlier, the topic of the webinar is we're going to give the quick overview of the UHI IOP. We're going to talk about the science of the Urban Heat Highland and where you can come in irrespective of your background as an educator, as a scientist, as a citizen scientist. We're going to tell you where you can come in. So the basic objective of this webinar is to highlight how you can come in this Urban Heat Highland investigation. We want you to study different surfaces at your school compound using the Urban Heat Highland investigation procedures, which oftentimes we refer to as step-by-step instructions, which is the surface temperature protocol that will help you to take surface observations across your school compound, across your site unit, which is what we are requesting from you as scientists, as teachers, as citizen scientists. We are interested in studying different surfaces, and you might be part of this team by investigating different surfaces in your school. You might want to look the surface temperature changes within your school compound. You might want to compare how asphalt or how concrete surfaces, the different changes between these surfaces, grasp, you can compare it with other surfaces. So this might be the point, this might be an object of interest to educators, students, citizen scientists. And tonight, I mean, it might be night somewhere here, but right here in Toledo, we're in the middle of the day. So this is just a quick overview of the webinar for today. We're going to talk about the quick overview of the webinar, which is what I'm doing presently. And then we are going to, one of our guest speaker, Sarah, she's going to talk to us on where you can come in as educators, where you can collaborate with the Globe Mission Health and the Globe program, and how you can be fully involved in the Urban Heat Island investigation. Then Sarah Tanzia will also be speaking to us on our doctoral dissertation. For a couple of years, she has been doing some investigation on Urban Heat Island. I think here in Toledo, she would like to tell us what she has been doing and how the study is crucial in understanding the cumulative influence of man on the environment. I'm not too sure if Dr. Yitong will be joining us at this hour because I just got an email from her. But Dr. C will give us a quick wrap up, then we go to Q&A section. Right, we'll quickly jump to our speakers. This is just the quick overview of our speakers tonight. I have with me Sarah Mezruaki. I think I'm okay. You are okay with that pronunciation. So she is the Globe Mission Head Project Coordinator at the University of Toledo, Ohio, and she has been working for a couple of years as the web developer for the Globe Mission, the Globe program as a whole. And she's also currently a member of the Science Technology Working Group, right? Technology Working Group of the Globe program. I'll quickly switch over to Sarah. She will be able to tell us more about herself as she dived into our presentation. Thank you, Sarah. Over to you.
Thank you, Femi. Appreciate it. And I think you'll have to allow me to share.
Yeah, I'm going to do that now. You could go ahead.
Okay. See if I can get this. Okay, so welcome everyone. My name is Sarah Merzwack. No ski on the end, Femi. Close enough.
Right.
And like Femi said, I'm the project coordinator for Globe Mission Earth. And I just wanted to start real quick on the Globe homepage. Many of you are probably already familiar with this, but just in case there are some new folks here, if you would like to join, you can go to globe.gov and go to training here. And I'm sorry, go to join and create an account, which is right here. And you could sign up. And then to get trained in Globe, you can go to the training. And there's actually fully virtual e-training modules here that you can look at. And if you're interested in the surface temperature protocol that we'll talk about today, you would go to Atmosphere and do the intro to Atmosphere and then scroll down, and then you can learn about how to collect surface temperature data by downloading that module. So again, everything is at the top bar here on the Globe website. Join, and then training is where you would find those. So collecting data for the Urban Heat Island study is actually quite simple. You just go outside with an infrared thermometer and collect your surface temperature data and hopefully also air temperature and clouds. But because the Globe website can be a little tricky to use, I actually created a simplified Google site for educators and specifically geared towards students. And this link, I will put this in the chat for everyone. This page is called Urban Heat Island Effect Page for Students. And it walks everyone through the process of getting into Globe and studying urban heat island. Um, at the top here, you can see I've got some photos of students around the world collecting data, some videos. And then if you scroll to the middle of the page here, there are three major sections. And the first section is learning about the urban heat island effect. And there are some activities in here, some links, some NASA resources. What is an urban heat island? There's the My NASA Data Urban Heat Island Story Map, which is an extensive resource with lots of different tabs in it that you can kind of see up here that you can explore and go through all the processes of their interactives in there. There's also some videos here, Climate Bits video about urban heat islands, another NASA video about urban heat islands, and then a cute cartoon video for kids, especially. Turf Mutt tackles the heat island effect, which is only 3 minutes, but it's super cute. And then if you keep scrolling down, there are some interactives for students to explore. This one is called the Climate Time Machine. And there's one about air pollution. And then, of course, the major issue that students often confuse, what's the difference between weather and climate? There's a nice video from NASA Climate Kids in there. So a lot of background science content in that section. And then if you go back and go to the middle section here, this one walks you through actually how to collect your data. And it shows you the instruments. So here's the infrared thermometer and the air temperature thermometer. And then you can also use the Globe Observer app to record those observations in addition to clouds. And you can see here that you collect your data, your surface temperature observations from the same cover type. So in this case, it's showing grass. And then there are also options if you don't have the app, you can just use hard copy data sheets, use a clipboard and go outside. And there are links here to the surface temperature data sheet if you just want to print those out. And then the guide to identify clouds is there. And then how to get that hard copy data into Globe so that it's in the Globe database. There's some instructions here. And then also some instructions on how to view all the data once you have that data in there, or you can just go right here and view other data that's already been submitted into the system. And again, on here's the link to our e-trainings through Globe. And then finally, the third section is to how to put all that together. How do you create a research project out of that data and how to share those results with the Globe community and with NASA scientists as well. So step one, map out your data and create a graph of your data, whether it's a bar chart or a line graph, and develop a research question out of that data. For example, which is hotter, the asphalt parking lot or the grassy field on my school grounds is a common research question, especially for elementary and middle school students. And then we have linked here also a poster template for you to have students put all of that information together in a formal presentation in a poster. And we have here, these are called sentence starters. So it makes it very easy for the students to fill in. And it looks complicated, but it's not. We've had very young students actually complete this whole process. And then there are links here to upload your research report to our Mission Earth page, which I can also show you. And then we also have multiple opportunities for symposia for children or for students to participate in. And the Globe program also has their International Virtual Science Symposium, which actually the deadline is next week, March 5th. So if you're not participating this year, that's fine. It'll open next year. But the Globe Mission Earth page, which I'll show you here real quick. Actually, I'll open a new tab. Let me a new tab. So this is the website that I maintain for our Globe Mission Earth group. And you can see here we've got all kinds of information about what is Globe Mission Earth and some news items about our latest activities. And here is this big section for teacher resources, not just for urban heat island studies, but for all kinds of studies in Globe. And then here is our student research page where you can actually upload a project here as well. And you can see all the latest reports that have been submitted through Globe Mission Earth in there. And I want to go back real quick. So I have that tab open already, but if you were to scroll down on that Urban Heat Island effect for students page that I created, there are examples of past student projects, and that's this tab that I have open. These are just a handful. This is certainly not comprehensive. There are examples from all different grade bands. So you can see here we've actually have some graduate student level projects. We have elementary projects, undergraduate, another graduate student, undergrad. This one is an elementary or middle school project, another elementary school one. So there are just a handful of examples here that you can check out for past student work with regard to surface temperature. So I will put our Mission Earth homepage link also in the chat. Go back. And our contact information, my contact information is in there, and it's also on the Urban Heat Island for students page that I created. So if you all need some assistance, feel free to reach out and let me know. And I think that's, oh, I did want to show one last thing, Femi, if I have one more minute here.
Go ahead, please.
Okay, so in addition to the Globe Observer app, which you all may or may not be familiar with, there's a website called dataentry.globe.gov. And if you go to that website, and I'll drop that in the chat as well, this is the web-based interface that mirrors the app. So this is exactly what you would see on the Globe Observer app if you install it on your phone. And if you can't do that, you can still reach it by going to dataentry.globe.gov to enter your data there. So I will put that one in the chat. And I think that's everything you want me to cover. Femi, is that good?
Right. Thank you so much, Sarah. That was so awesome. Thank you for joining us. I always look at the Google site that you developed, it was so helpful during the NASA sees internship. That was a very powerful resource. So I want you to keep your questions till the end of the program as we are trying to round up, maybe towards the last 10 or 15 minutes. We will attend to some of your questions. I'm going to switch over to, thank you, Sarah. Thank you so much. We are glad to have you. I want to quickly switch over to our next quest for today, and is a friend of mine, which we've met for a couple of years. Her name is Tanzia Ahmed. She's a doctoral student in the Department of Geography and Planning, right here from the University of Toledo. She came to know about the GLOBE program. I think that was about 2018 when she started, working with Dr. C, and she has involved in a couple of GLOBE activities, and I'm aware that she's also a NASA CIS mentor, and she has done an excellent, GLOBE activities when it comes to using surface temperature investigation area. She enjoys using geospatial skill to develop research ideas, and she has worked she's currently, let me just talk about her current research. She's currently focusing on Urban Heat Island, and that's her main PhD dissertation. I'm going to switch over to Tanzia to tell us more about what she's been doing for a couple of years. Yeah, Tanzia, over to you.
Yes.
Go ahead, please.
Thank you, Femi. Thank you, everyone, for inviting me here. I'm happy to present my research here. Please excuse my voice. I'm still recovering from a flu. So, so without further ado, I'll start sharing my screen. And okay. Mm, Can everyone see my screen?
Yes.
All right.
Which one is? Can you see the full slide or?
Right. I can see the full
Okay,
slide.
okay,
Right.
See
okay,
the preview.
okay.
I think
The preview.
Oh, your
Do
preview.
you want to
Okay.
blow it off? Yep. If you want to.
Okay.
Great. Great.
Yeah. So, thank you everyone for inviting me here. I think Femi already told about me, so I can just skip this slide. But I do want to give you some little background. So I'm originally from Bangladesh. I did my college in my bachelor and master's in geography and environment from Bangladesh. And then in 2018, I came to US in Toledo, and I pursued my degree in geography and planning. I wanted to get more involved with the planning sector and apply my skill. So here in 2018, I met Dr. C, and I learned more about Globe, and I learned became a Globe mentor, and from there. And then I enjoyed working here, and I started my PhD in 2021 in Spatial Integrated Social Science program. So and now that this platform, Urban Heat Island, I wasn't familiar with Urban Heat Island and relevant research back in Bangladesh, but it started when I came here. So I'm not going to talk about what I know everyone understands what Urban Heat Island is. So for me, it was pretty new, and I started looking at this topic. And the way I will present my research is I will talk about how I started looking at this topic, and then what works I have done so far and what I'm doing currently for my thesis. So while I was looking at the urban heat, in Globe, we are using the surface temperature, we are using the thermal sensors, and I came across these three type of way to look at urban heat island. One is the surface level, what we do with the handheld thermal sensors, which is just looking at the surface. And then the second one is we are looking at from surface to rooftop. The level we usually function. So, and then it usually uses the weather station or station data. And the third level where, the, it
wow, wow.
looks into the,
Si la kwenda da.
it,
Fa.
it looks into the from rooftop to atmosphere where another type of urban heat island effect is visible. And each have its own way of expressing the urban heat island phenomenon. And then I mostly worked on the surface level and the micro level. So this is an example, some of the levels I talked about earlier, the handheld ones. This is another one we do for for the canopy level. So from rooftop to from ground to rooftop. This is the drive around data where I don't know if it's visible or not. Okay. So drive around data where if you're familiar with urban heat and city campaigns going on, Toledo also participated, and where we collect the temperature and humidity, those data. And then this is also rooftop to ground. And then this is a surface temperature analysis. This is also from surface temperature, but this is from satellite using satellite, and this is another rooftop to canopy level. And it's usually, if we hold the camera, it will look something like this. So, so while I was looking at these methods, I tried different type of analysis and see where is the variation, what's going on. But most of my research is focused on the Toledo area. So, if you're familiar, I know most of you are familiar with Toledo, but this is, if you're not familiar with Toledo, this is the location of Toledo. We are close to Detroit. and then at the western basin of Lake Erie. And this is how Toledo looks like. This is the downtown area, and there are some big highways going through the city. And this is the river area. This is the Maumee River that goes through the city. And this is one of the outcomes. Before going into the topic, I wanted to show you how Toledo looks like. So this is an image I was processing from June 28, and it's from Landsat. So it's I use the satellite images here and try to see which areas are concentrated, where heat is concentrated, and it's a daytime temperature. So it's the cities are hot and the downtown area. There are some industrial areas here and some other pockets, and the rivers, as usual, looks cool. There we have a spectacular for metro parks here, so those areas are really cooling down in support of the city. So this is the preliminary work when I was looking into the urban heat and Toledo and trying to figure out what I want to do for my research. And this is a poster I created from those findings. So basically, this in this place, as you know, my interest is environmental geography and land use, land cover, and geospatial techniques. So I try to see where the heat is concentrated and is there a pattern? Does this change? So I looked at the land cover. I looked where if there are different what temperature is connects with specific land cover. So like high density developed areas are tend to be hotter in and which is also I found. This is just a preliminary thing, and I was also looking as does this temperature changes like in summer the temperature is it the heat pockets are similar or different. So this is here where I was looking at from 2014 to 2022, and I saw like it's similar. The heat concentration areas are consistent, and I looked to some hotspot analysis to find the clusters. And at the left of the poster, I just showed the distribution of the data from our city campaign, drive around campaign, and so as I was talking about the different levels and different type of urban heat situation. So the cities, if I use the boundary layer analysis, the cities look cooler in the 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 atmosphere. The heat from city tends to go downwind towards rural areas at night, and the downtowns keep emitting the heat, so downtowns are warmer at night, but the cities are so these are some of the changes I was looking at, and then I realized I am more interested to see how people are dealing with this heat and which areas are more vulnerable. So I wanted to look into the heat exposure aspect of urban heat island. So for heat exposure, it is the realized contact between a person and the indoor-outdoor environment that poses a risk of increases in body core temperature, perceived comfort. So basically, the environment, the exchange of heat. So I looked into the overall U.S. situation, and it seems the heat is affecting people, and people are more noticing heat. The CDC are putting out the websites about dealing with heat and heat events, extreme heat events. So in 2023, there were a large increase in hospitalizations in emergency visits due to heat, and the heat is also affecting a different type of affecting every people, but it is more people who are more sensitive to heat are mostly children, older adults, pregnant women, people with underlying conditions, respiratory conditions, and people who do not have access to air conditioning or working outside. So I'm trying to see which areas are looking worse in or throughout the city. This is this is I took from the CDC website that focuses on on the whole US, and you probably can see mostly the heat pockets are shown in the urban areas. Our Toledo is also in the high top 10% at risk situation. However, it is comparing the whole US, and I wanted to focus on more local. So I started asking question about what does the heat exposure looks like in Toledo, and what areas are mostly heat stressed, and then is there a pattern in variation throughout different scales like neighborhood, block growth, or census tracts, where to focus on for management. And then another thing is how does the demography and the socioeconomic elements are associated with the heat exposure. So it's not about causal relationships. Try to see when the heat, which areas are more hot, is there the association with the people living there are exposed to the heat. And then which locations are most vulnerable, and try to do a ranking so that the city can uh, manage the heat mitigation strategies better. So my objectives are to observe the heat exposure throughout the city, to investigate the association of heat exposure with socioeconomic characteristics, and thirdly, to identify areas that are most vulnerable to heat. Now, if you look at the whole thing, you can see the spatial heterogeneity, like the variation of urban heat is complex because it's not only just the temperature, it's the environment, it's the built environment, it's the physical variation like a slope, aspect, elevation, and also like the presence of vegetation, that what type of vegetation. So, and how clustered, how thick are those. So that aspects, and also the socioeconomic aspects. So these are all integrated, and so the way I try to do it is at the beginning I try to mod for my first objective. I try to model the heat exposure using all these elements, and then try to engage with the social elements, and then try to rank the cities. So I will mostly talk about the objective one for this presentation. Objective two, I just did I'm planning to do the correlation and regression analysis to see the association. And for third, it's just I'm going to do um, mm, a PCA analysis and see which are the highest ranking ones. So this is the where we are thinking about the model to understand how a human exposure looks like in outdoor. There are more people are exposed to different elements. There are buildings, and so the radiation coming from sun is heat. Going through the exchange process with human body. Uh, it can be long wave thermal radiations, or short wave ones, if you reflected, diffused. So what time we are running the model, all this comes into play. So it talks about the heat exchange, and so the model I'm looking at, it's a model that simulates spatial variation of 3D radiation fluxes, and measures the mean radiant temperature in a complex setting. So it uses the surface level, it uses the building height, it uses the canopy heights, the canopy positioning, and also it uses how much the sky view, consider sky view factors, the materials that the buildings are built with, the wall height and aspects. It also uses the meteorological data from that is available for long-term long I mean, there is long-term data from meteorological stations, so we can do the analysis, and I'm planning to run the analysis for July 2024, and the output will look something like this. You'll see the dark areas; those are like shadow, or and then the light areas, so where the sunlight is hitting mostly. This is how the model simulation will look like. So this is color coded, so the areas that are highly exposed to heat, people are more exposed to heat, those areas are red, and other areas the temperature is dropping based on the shadow, wind activity. So it combines the complex data set and give us a better heat exposure assessment. So the result will look something like this. This is I took a picture for city of Philadelphia, and this is how they can. So people who are standing in the middle of the street or right beside the tree, they will feel the heat differently, and this model will give us, depending on the position of people standing there, we can see like what is the heat exposure. And I'm planning to do a mapping like this, like census tract, neighborhood level, and try to see which areas are mostly concentrated with people are more at risk. And then I'll do my ranking based on those. So I am hoping to get a comprehensive map out of this research, and that will be able to tell people where the heat concentrations are, where people will be at most at risk, and it will help us to deal with the heat wave situations, which is getting frequent over years. And then the city can also look at this research and see where the most heat related budget should go, and then prepare a long-term plan for heat mitigation. So I hope to finish it by next year. Thank you for listening. If you have any question, I'll be happy to answer. Thank you.
Thank you, Tanzia. Thank you for that wonderful and intellectual presentation. That was awesome. I must tell you, I can't wait to see most of your findings in terms of looking at the rural-urban variations. And I really appreciate the way you connect urban heat island investigation to health, and the implications that the heat stroke has on humans. And that was just wonderful. I really appreciate you for finding time to be here. So if we have questions, we're going to keep it till maybe a couple of minutes before we round up. All right, Dr. Yitong will not be able to speak to us tonight. Do you have something to speak to us? You have something to say to us, right?
Yeah, I can speak. How many
Okay,
minutes
okay.
do we still have?
Well, you should do that under 8 minutes, right? Because we still want to hear from Dr. C, then take a couple of questions before we round up. So 8 minutes should be fine, right?
As Sarah mentioned, we actually two ends of our program are very friendly for everybody to participate and understand. The first is like Dr. C always told us, we're not listening to the lecture in the classroom. We go out to do science, and this is some photos that we have students go outside to test the temperature on different land surfaces. Actually, my background is similar, like Tanzia, come from China and come to United States for graduate school. And Dr. C was my master's degree advisor. And after that, I got my PhD and come back work with Dr. C on this again. And this is my dissertation topic on surface moisture in Indiana. And this is one of the results. So looking at this, many people won't understand what are those terms. So that's why I feel it's also important to communicate what we're studying to the general public and have people get more interested in what we're doing. And in our summer program with NASA SEAS, we also encourage students to use the story map from ArcGIS online to share their result. And many people did very well in telling a story. And besides this, I also work with a local nonprofit, and this is an example of how is urban heat in Toledo, Ohio. And I can drop the link in the chat later, but this is how the urban heat island in Toledo and the hottest areas. And the ranking of the hottest areas, like the Amazon warehouse, the downtown built area are the hottest area. And also we compare that with the people of color and also the median household income. So that is also try to communicate the result to different population and so people have a tangible experience of what urban heat island is and how that can affect their life, and where are the people that needs the most care. So Femi, because I see your agenda, you also want to communicate some case study from GME. So I didn't prepare a long presentation, but that's something I want to show.
Yeah,
Oh,
thank
Sarah,
you. Go ahead, please.
Oh, I say Sarah, open mic.
All right.
I'm muted.
Yeah, thank you, Dr. Yitong. Thank you. I didn't even have it in mind that you'll be able to join us again because I read your mail a couple of minutes ago. But thank you for finding time to be here. That was a very brilliant presentation. We've done a couple of works when it comes to Urbanite Highland. Here in Toledo, we've done, but I know maybe in our next webinar, we might be able to talk extensively on these, particularly the work that we did here in Toledo and Detroit by comparing how Urbanite Highland varies, comparing asphalt as well as comparing natural artifact, natural grasses, and compare with turf, which is the natural surface. But I think the other time we'll have time to talk extensively on this. I want to quickly switch over to my slide to tell us the collaboration that is going to be in existence between the Globe Mission Head Urbanite Highland investigation observation intensive observation period with the Globe View intensive observation period. We are initiating a collaboration with the Globe View intensive observation period that is going on right now. And I'm here to hear from Nelson Perdel, which is the main point of contact of the Globe View intensive observation period. So hopefully he might come to share some of his findings with us in our next webinar, which is going to be in April 28th. We are looking towards our third webinar, which is going to be the same time. And we'll be looking at what to do with your data, a lot of data comes from urban heat island investigation. So that's webinar. We're going to dive deeper into what you can do with your data and how you can communicate the findings of your investigation to the community or people that are interested in. All right, I'm going to switch over to Dr. C. I'm quite aware that I might want to share one or two things with us.
Oh, okay. I thought you were going to share a slide that showed the snow cover project that is just finishing up and then switching to urban heat island.
Oh, okay. Are you
Did you
talking
have
about
that?
this?
Yeah.
All right.
So some of you maybe have been involved. I know many of you live in tropical countries, so no. But in the northern part of the world, the snow campaign for GLOBE is just wrapping up. And so people were to take snow observations and then pictures. And what we're learning is that the snow stays on grass longer than asphalt and pavement. Well, and that's the same as with urban heat island, is that the asphalt and pavement tends to be warmer than the grass and vegetated areas. So those two are connected, and Peter Nelson wanted us to talk about that, how the campaign that's just finishing up on snow now is we're transitioning into the campaign on urban heat island, but they are related because they're related to land cover. All right, so Femi, is that what you had? And then I'll share a screen and then we'll take some questions. Okay.
Yeah. So I'm gonna switch over to. Yep. I think this you can share a screen now, right?
All right. So we saw today how Tanzia talked about her research, and then the city of Toledo, and people drove the roads taking observations. And then Yitong talked about her work in using remote sensing. But a lot of it began with GLOBE and doing GLOBE urban heat island observations in our community. And you can see here on this map, Toledo is a place in the world where a lot of GLOBE observations are taken. This was for December, the intensive observation period we had in December. There were 540 sites, which equates to a little over 400 schools participated. I thought that was a real good number for the world. And you could see across the United States, the Western United States didn't have a lot of observations. We have one school in Brazil that participated, Nigeria, Ghana, the Canary Islands, Spain. Croatia had a number of schools, many number, Malta, Greece and Macedonia, Israel, Egypt, Saudi Arabia, Oman. Let's see, I think that was Qatar, Kenya, India. I think that's, I can't forget Estonia, Ukraine, and Russia. There's Thailand and Taiwan as well. So all these places participated in our campaign in December. Well, of course, we're hoping for even more participation this go around. And I can share just a couple slides about what to do. Oh, I'll share this history. I found these old pictures from 1999 where I was using the infrared thermometer to take surface temperatures in the Southern Great Plains study, 1999, SGP 99, that NASA did. This was a precursor to the SMAP satellite. And of course, SMAP is a soil moisture observation for GLOBE. But I said, well, if I can take observations with an infrared thermometer, this was a prototype that cost $3,000, by the way, then students can do this too. And I'll just skip down. We had students go to the White House to do the science fair there. Let's see, I had something in mind. But, oh, okay, here we go. Here's some of the nuts and bolts. This is from the e-training that's online. So Sarah showed you the e-training. So you can look at that, but I just want to go over a few things. Use your infrared thermometer. You can take your observations any time of day. You don't have to worry about local solar noon. That's better, but it can do any time of day. Here's our infrared thermometer that you use. There are a lot of different ones. Plus or minus 2 Celsius is our error that we're looking at. If you want to test the accuracy of your infrared thermometer, use an ice water slurry, put a regular thermometer in it to make sure it's about 0 Celsius. And we want plus or minus 2 with your infrared thermometer. If it doesn't measure right, try changing the battery. That might help it. All right, we'll skip that. Okay, so we tend to want you to take observations of 2 different cover types, usually some kind of grass and then some kind of pavement. If you don't have grass, it could be a mulch, it could be a bush, or it could be 2 different types of pavement. You can see in this image of my children's school, we have asphalt, we have cement, here's grass, the playground is mulch, and then the baseball field is like a gravel. So try at least to take observations of 2 different cover types. But each cover type, you need to, that's a different site, all right? So if you do grass, you need to have the location of the center of that site. And we would like you to take 9 observations using your infrared thermometer. That gives us a good average. But you can take 1. 1 is fine. 3 is better. 9 is best. All right. Do not mix the cover types in those 9 observations. If you do the gravel here, that's a different site, and you have to submit it as a different observation, just to be aware. Also be aware, don't have the kids take the temperature of their shadows. This is my youngest son, Timmy, who's now 21 years old, and he's 6 foot something tall. He was little then. Don't take the temperature of your feet. And I think we'll stop there. All right, well, that's what I wanted to talk about. And then we have this great presentations from everybody else.
Thank you so much, Dr. C. That was awesome. I wonder where you pull those old pictures from. That sounds interesting.
They were actually on the photos, actual pictures.
Great. Yeah, so before we quickly round up, let's quickly take questions, 1 or 2 questions before we round up. Questions, you can put them in the chat box. All right, I have a question here. All right. Stop sharing my screen so I can read the question. All right, I think Nectaria just, okay. All right. Thank you, Nectaria. Thank you for the lovely message. All right. Okay, Dr. David, thank you. Dr. Paget, thank you. So you could put in your question in the chat box. Okay, yeah. Let me grab Imani's question. Yeah. To create heat highland maps for specific areas, as a user-friendly platform or tool that can be used and accept data collected using Globe protocols without requiring one to be a scientist or academic, ? Is there a platform that can be used by the general public to model a set of variables to determine heat island in an specific area? I'll throw that question to Dr. C. That's Darwin.
Yeah, well, I'm trying to find we have a Google Earth Engine app, and it's very helpful for mapping local areas. I'm trying to find the link. I lost it because my laptop died, so now I have a new computer. Does anybody have that link? Yitong or Tanzia?
Is this Tamina's Google Earth Engine link?
Yeah, Tamina's. Yeah. I think I found it. All right, let's see if we can.
While you're pulling that up, Ichem put a question in that says, why focus on the months of October, December, and March?
Yeah.
Because that's what we can do.
Yeah. Yeah, we're also pushing forward to see how we can extend those months. I think I contacted Benbujo, right?
Yeah,
So,
July is a good month.
yeah.
In the Northern Hemisphere. So this app, you can go anywhere in the world. Let's see, who asked that question?
Darwin?
Where's Darwin from?
Yeah, Darwin.
I'm here.
Where are you from?
I'm from Ecuador. Quito,
Ecuador.
Ecuador.
Okay.
Right.
Yeah, my sister-in-law lived in Quito. She managed the Marriott Hotel there for a while. Okay, we'll zoom in on Quito. All right, so you click on the rectangle and you draw a box. Then you go around the right, and there's instructions. Choose Landsat collection. Oh, I think choose Landsat 8. It has a longer record than the others. We'll click on the service temperature NDVI. We have to pick some dates. I suppose we have to go away from like right now because it takes time for the data to get in the system. So if you pick dates that are too close to now, it won't work. Let's go to October. Okay, come on, scroll. There you go. We have to choose a temperature range. We're trying to fix that because, choosing a temperature range is kind of clumsy, and then add data. Let's see if it works. Sometimes it doesn't work. Oh, that looks good. There's NDVI and there's our temperature. All right. So then we can turn on and off layers. All right. NDVI is vegetation. So white means low NDVI and red is high temperature. So you can, if we zoom in here, I think this is Quito, right? Here's the city. We have the rural around it. Of course, it's in mountains, so that's a challenge, a little different. But the areas that are city are warmer than the forested areas around it. We can look at that. All right. There you go. Use that app. Okay, so and I don't know if everybody doesn't realize how impressive that is to be able to do that. I've been working in remote sensing for 30 years. Well, I took my graduate courses before that. It's now this is something we've been wanting to do for 30 years, but now we can do it using Google Earth Engine.
So there are 2 questions from Imani in the chat about Tanzia's presentation.
Okay.
And the first one was, I wonder if temperature comparisons were made at locations near bodies of water, industrial parks, shopping malls, parks, etc.
Yeah. Do we have Tanzia there? Do you want to respond to that? Right.
Yeah, so when so I didn't necessarily looking at different industrial parks or shopping malls, but what I did is I took land cover data from USGS, and what they do is it just shows you where is the high developed area, where is the open field, where is some grass covered area. So and then I did this comparison on that. However, I did look at the areas where the temperature were lower or higher. Some of those areas were industrial building, like there is a tool and die industry that has a higher temperature emitting in that area. And then there's the rivers were cooler. So I didn't necessarily compare different features like a water body or different type of buildings, but that's what I just did for my preliminary research. Yeah. Thanks for your question, though.
All right. Thank you, Tanzia. Thank you so much for responding to that question. So we should be on our time. All right. So I want to quickly thank everyone who made it possible today to be here. All our participants. We have a wide coverage from Africa, from Taiwan, from United States, from Ecuador. We want to thank you. And if you have any other questions, here is our contact. You can shoot Dr. C an email, or Sarah is our project coordinator. And you can as well go on our website, shoot on that email if you have any questions. We'll be willing to respond quickly. And upcoming webinar, the next one will be on April 28th, same time. And the last webinar, which is the fourth webinar, is going to be on 16th, May 16th, same time. All right. I want to thank all our guest speakers. We really appreciate you, and to all our participants, thank you for joining us today. Bye, everyone.
Thanks, everybody.
Bye, everyone.
Bye. Thank you, everyone.
Thank you.
Thanks. It's great.